Hey everyone, Mr. Skelton here. We are back at it for lesson 2 in unit 4, and today we're going to continue our conversation about polynomials. And a lot of this actually is review because you did a lot of this with what you did in your quadratics unit. Today we're going to be doing a couple things. Number one, converting polynomials between factored form and standard form. If you want to think of this in terms of your review, this is like going from vertex form to standard form. If you recall, we went last unit in our quadratics, we went from from vertex form. This was vertex form, good to remember, and we had to convert that into standard form, and that just required essentially just PEMDAS. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally, right? And and so you're going to be doing that today with polynomials. The second thing is being able to find the relative min and max of points. And you've actually done this before. You've done max points, like if you had a parabola, which is what we just got done doing with our quadratics lesson, you had to find the max, right? That's the max, which is also your vertex on a quadratic. So it'll be a little bit different today because we're dealing with polynomials, and so you'll have degrees higher than 2, right? This is a y equals x squared, negative x squared type function. But a lot of the stuff that we're going to do today, you should have some idea of, or you'll have a connection at least from last unit. So let's jump right into it. I want you to kind of ignore this stuff on the right here. Obviously you have the answer that we should get, and then we'll talk about a little bit what it looks like on a graph, and we'll talk about the zeros as well, but we won't get in too much detail into the graphing. So it says write this equation in standard form. Again, you've done this before. This is multiplication here in the middle, x plus 5 squared. Remember, that means x plus 5 and x plus 5. Based on some of the stuff that I saw on our last test, some of us still need some work on distributing or foiling, however you want to call it. But essentially what happens is you get the 3x minus 7. I would leave that alone. When you distribute here, you're going to get x squared plus 10x plus 25, right? If you add these together, just think reverse factoring. If you add these together, you get your middle term. If you times them together, you get your last term. So that's how you can quickly multiply two binomials together. And then you're going to have to distribute twice here with this 3x. So this takes a little bit of time. So let's go through it. And you got to go real slow and be real careful. So I'm going to get 3x times x squared, which is 3x to the third. 3x times 10x is going to be 30x squared, and 3x times 25 is 75x. And then we need to distribute this negative 7. You have to treat that like a negative 7. So negative 7 times x squared is minus 7x squared. Minus 7 times 10 is a minus 70x. And minus 7 times 25 is a negative 175. Now we got to put our like terms together. So 3x to the third stays because that's all I have. I have a 30x squared, and I have a negative 7x squared, so add those two together, or subtract them, however you want to think about it, and that's going to be 23x squared. You have 75x and a negative 70x, so add those together, you get 5x, and then you have a negative 175, okay? And so that's all you really asked to do in this question. It just says write in standard form, so this would be our answer right here. From yesterday, this would be a cubic. If we were to name this, this would be cubic because the highest degree is a 3. It goes 3, 2, 1, and none. That's our constant. Remember, your last term with no variable is a constant. And this is a 1, 2, 3, 4 term polynomial. Okay. All right. Now, it says, this is going to help us out more in the future. It says, what are the zeros? If you remember, when we did our quadratics. When we did our quadratics, our zeros are where it crossed the x-axis. And so you always use factored form to find your zeros, because if you take this, for example, get to it here, that is considered our factored form. So essentially what we did in this problem is we went from factored form to standard form. That's important to understand that this is factored form right here. Now if we were to take those and set those equal to 0 to find our zeros, or what x equals, that's something like this. 3x minus 7 equals 0, and x plus 5 equals 0. And if you were to solve this, you'd get x equals 7/3, and if you solve this, you get x equals -5. And so we're not going to do this yet, but 1, 2, 3, 4, 5, that would be a 0, and 7/3, so basically a little bit more than 2, right? So 1, 2, 3, that would be another 0. This is where, when you were to, if you were to graph this, this is where it would cross the x-axis, okay? And we're not getting into the graphing part, but if you were to graph this, and I put it in my graphing calculator already for you. I know you can't see that yet. There we go. I put that polynomial into my graphing calculator, and if you hit graph, you can see what the graph is going to look like. And we're going to get into graphing a little bit later, but just to kind of give you a heads up, this graph, again, this is something cubed, so it's going to have this action here. This graph would look like that. And I'm going to teach you how to graph these a little bit later, more specifically, but you can always use your graphing calculator to graph it. I could probably adjust my window here so I could see the whole thing, but again, we're really not going to spend a lot of time in graphing. The biggest thing that I want you to take away from this slide is essentially this: taking something that's in factored form and putting it into standard form. Also understanding that you take your factored form to find your zeros and solve, what you did when you did the quadratic lesson. Okay? All right, so on the back, this slide number 2 says writing equations in factored form. So it says write this equation in factored form. All right, so essentially we're just doing the opposite of what we did on slide 1. Here's something in standard form, and we want to put that into factored form. So what do we need to do? We need to factor. And a lot of us still struggle with factoring. What's the first rule of factoring? Rule number 1, is there a GCF? If there is, you have to take it out. So take a look at all 3 terms here, 1, 2, 3. Is there a number? Let's look at the numbers first, 2, 2, and 40. Is there a common factor in all of those? Yes, 2. Perfect. Okay, let's look at our x's, x cubed, x squared, and x. What's the most amount of x's that each term could share? The answer is just a single x, right? You couldn't put x squared because this only has 1, so 1 is the minimum. Then what we need to do is factor this out. Now, whether you use multiplication in your head to get the rest of the terms or division, it's up to you. I use multiplication, so this is how I would factor a 2x out of this. I would say, okay, 2x is my GCF. What times 2x gives me 2x third? Just x squared, because I know that 2x times x squared is 2x third. What times 2x gives me 2x squared? Just an x. And what times 2x gives me a negative 40x? That would be a negative 20, right? And then just double check. Does this times this give you 2x to the third? Yes. 2x times x, 2x squared? Yep. 2x times a negative 20 is negative 40x. Perfect. Now, don't stop here. Once you've taken out a GCF, look to see if there's something else you can factor. Can you factor this trinomial into a product of 2 binomials? In other words, are there 2 numbers that multiply together that give you negative 20? Add together, you get positive 1. There it is. You have x plus 5 and x minus 1. 4. 5 times a negative 4 is negative 20. Check. 5 minus 4 is a positive 1. Check. So this is our answer. We went from standard form to factored form. Okay? And you can see the answers right there. Now it says, what does the graph of this look like? What are your zeros? Remember, to find your zeros, you take your factored form and set them equal to 0 and solve. So if I was to do this, I have 2x equals 0, because you have to set that. You have x plus 5 equal to 0, and you have x minus 4 equal to 0. Again, you take all your factored form, set them equal to 0, so you have x equals 0 here, x equals negative 5 here, you have x equals positive 4 here. So if we were on our graph, we would put dots at our zeros, 1, 2, 3, 4, negative 5, positive 4, 1, 2, 3, and 4. Okay? And what we could do is, again, for right now, because we're not really spending a whole lot of time on the graphing component, But if you wanted to graph this, I'll kind of zoom out just a little bit here. So maybe you can get my whole graphing calculator in the picture. And I'm just going to type in the 2x to the third. Now, you go 2x. Now, we don't have an x to the third button over here, so we use our caret button, which is right here. It's like an upside down V, caret button. And then 3, so that means 2x to the third, plus 2x squared. There's your x squared button here. And then minus 40x. If you hit graph, it's kind of goofy looking, and again, we could zoom out of this so you could see it. I could increase my windows, so I need to increase my maxes on my y. So let's go y max, we'll go 100. My y min, I'll go negative 100, and I'll scale it by 10. So let's see if that works. There we go. And there's your graph. And I'm going to teach you how to draw this by hand, but this graph's going to go up, oops, and through and around, and there's our graph of that function. And these are zeros. You found your zeros here, here, and here. That's where the graph crosses. Those would be your solutions of the polynomial where y is 0. So, okay. The last question on here, again, this is pretty challenging question. So I'll walk you through this one. But it's a good question, but it is a bit of a challenge. It says the length is, we're talking about carry-on luggage, right? When you go to the airport, you have a carry-on bag, and it's got to be a certain size, right? TSA has rules about how big your carry-on luggage can be, and that's always a pain in the neck. They're changing them and making them smaller every time. But here's a situation where we have carry-on luggage rules. The length is 10 inches longer than the width. The sum of the length, width, and height is less than 40. What is the maximum volume? Okay, so there's a lot going on with just a little bit of information here. So let me kind of walk you through this. First of all, let's talk about what are we trying to find? We're trying to find volume, right? So volume equals length times width times height. Let's start there. We got to start with that equation. And then what we need to do is we need to generate an expression for the length, width, and the height. So it says the length is 10 inches longer than the width, okay? So if the length is 10 inches longer than the width, our width is going to be x. Our length is going to be x plus 10, right? The length is means equals, length is 10 longer than the width. So if the width is just x, that's what we have. So our height, this is the hard part, is writing our height. The sum of the length, width, and height has to be less than 40. So what we're going to do to express the height is going to be 40 minus the sum of x plus the 10, right? We know that the height has to be 40 less, so 40 is our number. The height's going to be these two things subtracted from 40. That's going to leave you with the height, okay? So those are our three expressions, x plus 10, and then 40 minus this. Now we can simplify this. We can run the negative through, so that becomes a negative, that becomes a negative, and that becomes a negative. So that if you do the quick math, you'd get a minus 2x, and then 40 minus 10 would be 30. So you'd get basically 30 minus 2x. That's going to be your height, all right? And it says, what is the maximum volume? So what we do is we take length, which is x plus 10, times the width, which is just x, times the height, which we just did and simplified, and there's our volume. Now it says, what is the maximum volume that we can find? What do you remember when we did problems in quadratics, what maximum meant? Well, if you remember, we had problems like this, right? The rocket or the ball is thrown into the air, right, like this. What is the maximum height? What did we have to find? We had to find that vertex. We had to find the highest point of the graph. This was time, this was height. Very similar to this problem, what we want to do is we want to graph this, okay? We want to graph this. When you graph this, And I'm going to do it in my graphing calculator with you. So get my graphing calculator out. I'm going to make this a little bit smaller here. And I'm going to go to y equals. I'm going to clear that. I'm going to reset my calculator because I think I had something left in here from before. Just a quick reset. Go to y equals, and now I'm going to type in, and I'm going to use parentheses, so I'm going to go x plus 10. I'm going to hit my times button, times x times 30 minus 2x. I hope this works here. Okay, now we have to do some thinking here outside the box. So we have a bag, right? I want you to, nothing's really showing up on my graph. So we're going to have to adjust our window, but what do we need to start thinking about? Like, how would we adjust our window? Well, let's think about this for a second. A bag. We're talking inches, right? 10 inches. Length is 10 inches. So let's just say everything was, you know, close to 10. If you had like 8, 9, and 10 as your dimensions, what would that number be for your volume? So let's think about this for a second. So you can just quit and go 8 times 9 times 10. You got 720, right? So I'm thinking your volume is close to 720 cubic inches. So when we graph this, this is 10, 10, and 10. And we want our volume, obviously, is going to be on this axis right here. So we need to increase our windows a little bit. So I'm going to go to my y min. I'm going to go 1,000. Oops. To be on the safe side. And then my y max to be 1,000. And let's graph it and see what we get. I'm getting closer. So I still need to increase my, you can see here your x is going to be a negative 10, which you can kind of see there. If you solve for x here, we're talking zeros. That's going to be a 15. So I need to increase my y's even more, and I need to increase my x's a little bit more. So I'm going to go x max 20. I'm going to scale it and go by 5s. I'm going to go my y min. I'm going to go 1,500. I'm going to go max 1,500. And I'm going to scale it. I'm going to go 100. So that means each dot is 100. Let's see if I can see it a little bit better. Ooh, I still need to go even higher. All right. I'm going to go window, y max. I'm going to go 2,000. Let's see if that gets in. Well, I'm going to go a little bit higher. I'm getting closer though. About 2,500. That's got to work this time. There we go. Okay. So there's my graph. So the question says, what's the max volume? So if you relate it to what we did over here with my example from quadratics, we know my graph is going to look something like this. All right, my zeros, that's a negative 10, because if you solve that for x, right, you would subtract 10, so that's your 0 here. This is just x equals 0, and this is going to be 15. Now, this question isn't asking what the zeros are. It says, what's the max volume? Well, we want to find that point right there. We want to find the x value that gives us our biggest volume, which in this case would be our y. So here's how we do this. We're going to go to second calc. We're going to go to maximum. We've done this before. Hit enter. It's going to say left bound. Are we on the left side of that point? We are. Right bound, we got a cursor all the way over to the right hand side. So I'm to the right. Hit enter again. And I'm not going to call it a vertex. This is called a relative maximum. Okay? It's a relative max and a relative. We have relative maxes and relative mins. I'm going to tell you or explain to you why it's a relative max. So, relative max. The reason it's a relative max is because if you look at this arrow, what does this arrow mean? It means this graph's going to go up forever. So the maximum of this graph is positive infinity because this is going to go on forever. So we call this a relative max because it's the maximum of the function with the hump there that's going to give us the greatest volume in this case relative to the x values. So if you look at your answer here, you get x equals 8.93, and you get y equaling 2052.2. So what does that mean in terms of the problem? Well, our 8.93, that is our width, because that's what x is. The length is going to be 18.93, because it's that plus 10. And then we could plug it in here to find our height as well. But the question is, what's the maximum volume? Because this is our volume, and this is our x, which is our width. Our volume is going to be 2052.2. Okay? I put the width in here as well, but I was giving you the length width. I can find the height real quick. If I go, let's see, -2 times 8.93, then I'll add 30 to that, and that gives me 12.14. So that's my height, that's my length, that's my width, and that gives me a volume of 2052. So a tough question, a lot going on, but a lot of it is kind of connected to what we've already done. And so, again, really what I want you to get out of this lesson is really two things. Well, I guess I should say three things. Number one, that you can go between factored form and vertex form. So that's what we did on the first two examples. And that you can find the relative max and min of points. Now you may be wondering, well, we didn't do any minimum problems. It's the same exact thing as you did on this one right here. If I asked you to find, I'll just use this example. If I asked you to find the relative min, that would be right here. That would be your relative minimum. And if you go to your graphing calculator and hit second calc, there's a minimum button right there, number 3, and you would do the exact same thing. Okay? If you have questions, especially with your graphing calculator, I'd be happy to help you out. I look forward to seeing you in class.